Hello, this is Miss Moore, and today during chemistry we're going to discuss heat flow and phase change. Today's essential question: how is heat used to change the states of matter? Let's start with a quick overview on the states of matter and physical change. So there are three basic states of matter, and that is solid, liquid, and gas. There's also plasma. We're not going to talk about that. Okay. Gas molecules have the most energy, more energy than solids or liquids, because the molecules are free to move. Molecules of a solid have the least energy because the solids are tightly joined together. Phase change. A phase change is a change in state. So going from a liquid to a solid, a liquid to a gas to a liquid, whatever. And phase change always involves a change in energy and thus a change in heat. All right, so let's go over some terminology relating to phase change. If we're going from a solid to a liquid, we are melting. If we're going from a liquid to a gas, we are evaporating. And if we're going all the way from a solid to a gas, we are subliming. It's called sublimation. Now, something to keep in mind here is molecules of a solid have the lowest energy, and molecules of a gas have the highest energy. So what we're doing here is going from a state of lower to higher energy. Okay, so to go from melting to liquid, melting going from solid to liquid, or evaporating going liquid to gas, you're needing to absorb energy because we're going from a lower to a higher energy state. Because you're absorbing energy, we're going to call these endothermic processes. All right, we can also do phase changes in the other direction. Going from a gas to a liquid is condensing. Going from a liquid to a solid is freezing. And going from a gas to a solid is called deposition. Okay. Once again, solids have the lowest energy, and gases have higher energy. This time, though, we're going from a high energy state to a lower energy state. Going from a gas to a liquid, liquids have less energy than gas. So in this case, we're releasing energy, again, because we're going from a higher to a lower energy state. So we call these processes exothermic. And we'll stop here for part one. Make sure you know all this terminology. Okay, gas to liquid is condensing, liquid to solid is freezing, etc., as well as which ones are endothermic and exothermic, and why. All right, have a good one. Let's start with a discussion on heat diffusion. So heat diffusion, or delta H fuse, is the amount of heat needed to melt or freeze 1 gram of a substance. If we're talking about melting or freezing, we're talking about the two phases of matter, solid and liquid. Right? So if we were melting, we would be going from solid to liquid, and if we were freezing, we would be going from liquid to solid. So heat diffusion deals with the transfer or the change of state from solid to liquid, liquid to solid. Okay? So for heat diffusion, there is an equation. It's Q equals M times delta H fusion. Q is the quantity of heat, and that will be either in calories or joules. Those would be the units. Then you have M. M is the mass of the substance, in grams, of course. And delta H fusion is the heat of fusion. It's different substances have a different heat of fusion. Okay, that's a constant per a particular substance. Next up, heat of vaporization. Heat of vaporization, or delta H vape, is the amount of heat needed to either vaporize or condense 1 gram of a substance. So if we're vaporizing or condensing, we're talking about the liquid and gas phases. So if we're vaporizing, we're going from liquid to gas. And if we're condensing, we're going from gas to a liquid. We have an equation for heat of vaporization, which is exactly the same as heat of fusion, except for, so we have Q equals mass times delta, but this time it's vaporization instead of fusion. All right, so again, Q is the quantity of heat in calories or joules. M is the mass of the substance in grams, and delta H vaporization is the heat of vaporization, which is a constant, again, for a particular substance. Every substance has its own delta H, or heat of vaporization, just like every substance has its own specific heat of fusion. So now let's try a couple practice problems. So the first one is, how much heat is needed to vaporize 75 grams of water? So we need to know, first of all, if we're going to be using the equation for heat of fusion or heat of vaporization. But we're vaporizing, right? So we must be using the formula Q equals mass times delta H vaporization. Now we just plug this in. Q is the amount of heat. We know we have 75.0 grams, and we're going to multiply that by the constant for water for heat of vaporization, which is 2,260 joules per gram. So grams will cancel out, and when we multiply, I got 169,500 joules. All right, practice problem 2. If you can, why don't you hit pause, try to do this without me, and then hit play and see how it went. All right, so this time we are looking at heat of fusion. So we'll be using the formula Q, which is the amount of heat, equals the mass times the heat of fusion. Okay, this time they give us a heat unit, so that must be our Q. So we'll have 2150 joules equals, they give us the mass, which is 56.5 grams, and what we're trying to find this time is the heat of fusion. So, to solve for x, we'll divide both sides by 56.5 grams, and that gives us 38.0530, etc. joules per gram. The heat of fusion, so the delta H of fusion for sulfur is 38.1 joules per grams. All right, that's it for today. Have a good one.